Okay, so we've been solving this equation. We've determined that the left-hand side integrates to give us 1 over L times the natural log of the absolute value of y minus 1 over L times the natural log of the absolute value of L minus y. There's an integration constant, but we've already got an integration constant on this side of the equation, so we won't worry about the integration constant from this side. They can just be absorbed into one constant. And we see that the right-hand side is just kt plus c. Now, that's the solution to this logistic equation, where c is still an arbitrary constant. We want to simplify this side a little bit, so we're going to say that, well, we can factor out a 1 over L, and we have natural log of y minus, well, let's do that, 1 over L times the natural log of absolute value of y minus the natural log of the absolute value of L minus y equals kt plus c. Now, when you subtract two natural logs, that's the same as the natural log of this divided by this. So we have 1 over L times the natural log of the absolute value of y over L minus y equal to kt plus c. We can multiply through by the L. We get natural log of the absolute value of y over L minus y equals k L t plus c, c absorbing the multiplication by L. And then we take the exponential, raise both sides, e to this power equals e to this power. E to the natural log of something is just that something. And on this side we get e to the k L t plus c. As we did with the solution to the unrestricted growth problem, we're going to factor this side. We're going to get e to the c, e to the k L t. On this side we're still going to have absolute value of y over L minus y. And e to the c, c being an arbitrary constant, e to the c being some positive number, which could be as small or as large as we desire, just by letting c be some number between negative infinity and infinity. We get a e to the k L t, where a is greater than 0. Now that's equal to the absolute value of y over L minus y. We still need to solve this equation for y in order to see what our final function looks like, but the mechanics of the process are straightforward enough if you know the basic techniques of integration and properties of logarithms. This is just an exercise in algebra.